All right, today we're getting a look at graphing linear inequalities on an XY coordinate grid. Now, previously you had been working with something that may have looked like this, x is less than 5, and we've been graphing that on a number line, right? So we'd have to say, okay, open circle, and then we'll say x is less than 5, so the circle is going to go to the left, right? So that's one variable, and as a result, we're graphing that on just a number line because that's sort of a one-dimensional way to graph, right? So now we're working with two variables. So we'll be working in the XY coordinate grid because now I have X's and Y's in my inequalities. So let's see how we can go about doing this. Now, the first thing to note is that I have two different types of inequalities, right? I have inclusive and exclusive. So for my exclusive ones, okay, this is going to result in a, similar to how this might result in an open circle, right? On my number line, this is going to result in a dashed line. Okay, and you'll see what I mean here in a second. So that's going to be a dashed line, and my inclusive inequality signs will be a solid line. Okay, that kind of corresponds to the closed circle that we saw in our one variable inequalities. So first thing we're going to need to do is think about what we're going to call the boundary line. Okay, so the boundary line is, to find that, I'm just going to change my inequality into an equation. Okay, so I've got y is equal to, sorry, this should be -2. Okay, y is equal to -2. I need to think about what does that line look like. Well, that's going to be a horizontal line, okay, at -2. So I'll just go ahead and draw my horizontal line there at -2. Okay, so this is the boundary line, y equals -2. Okay, so now I need to just choose some points, and I'm going to choose points and then test them to see if they yield a true statement or a false statement. So I'm going to choose 0, 0. That's an easy one. So over to the right here, I'm just going to plug in the y value for 0, 0, which is 0. So 0 is greater than -2. That is a true statement. Okay. If I choose another point, like down here, I'll choose 0, -4. And I plug that into this inequality, this first inequality, that would look like -4, that's my y value, is greater than -2. That is a false statement, right? Okay, so what we want to do is, what we're doing with these, well, you'll notice our command is to indicate the region that satisfies all three of these inequalities. So what we're going to do is we're going to sort of indicate that this region below this line does not satisfy the inequality y is greater than -2. Okay, so we're sort of eliminating regions that don't satisfy each individual inequality. Okay, now you might be looking at this next one and thinking, okay, what does x plus y equals 5? What does that look like? Well, it's a little bit easier if we just try to rearrange this in terms of y equals mx plus b. So I'm just going to subtract x from both sides, so that's -5x plus 5 equals y. Okay, so that's going to be here on our y-intercept is +5. We have a slope of -1. Okay, so it's going to look something like that. Now, again, I have a exclusive inequality, so that's going to be a dotted line. So I will just draw my dotted line in there. Okay, so that is my boundary line there. And again, I'm just going to pick some points here. So I'll use the same 0, 0 that I used earlier. So now I'm going to plug 0, 0 into this inequality, my second inequality. So that would be 0 plus 0, because my coordinates are 0 and 0, is less than 5. So that's going to be true. Okay. Now, if you chose some other random point on the other side of the line, so I'll pick 6, 6 over here. Okay, so that would be 6 plus 6 is less than 5. That's going to be false, right? Because that's 12 is less than 5. That doesn't make any sense. So I'm just going to indicate that this region does not satisfy that inequality by shading it in. Okay, and we'll just do the same thing with this last one. So I'm going to rearrange this to be y is equal to 1/2 x plus 1. So I've got my x-axis intercept, or my y-axis intercept at 1. Okay, using my slope of 1/2, I can get a few more points in there. And I notice that I have an inclusive inequality, so I'm going to have a straight line for a solid line for my boundary line here. Okay, so that's my boundary line. And we're just gonna test some more points. So I'll use 0, 0 again. So that would be 0 minus 1 is less than or equal to 1/2. Okay, so just plugging in, not 1/2, but 0 over 2. So that simplifies to be -1 is less than or equal to 0. Okay, that is a true statement. Okay, so I can pick another value, but if we do, we're going to find that some point over here on this side is going to give some false statement. Okay, so I'll just go ahead and shade this side. You can test that if you want. Okay, but what we have here is this unshaded region, all right, is the region that satisfies all three of these inequalities. So previously we had seen systems of linear equations. Okay, what we have here is some region that satisfies this system of linear inequalities. Okay, and again, this is on an XY coordinate grid, and that's sort of what the process will look like.